Well, welcome everyone who's joining us from around the world for the Gilder Fellows 2021 Life After Capitalism. Thanks for joining us. I'm Jay Richards again. For those of you who may have not joined us yesterday, may be new today. The format for today is exactly the same as it was yesterday. So we'll have basically 3 hours of presentations and discussion, and then a virtual lunch afterwards for those of you who are able to join us. We've got a lot of interesting topics, and so I don't want to spend a huge amount of time going over that, but let me just tell you what you can expect today. So first, we're going to hear from George Gilder, whom you probably already know, and so I won't introduce him. And then Scott Powell, a senior fellow at Discovery Institute, is going to talk about woke capitalism, which is a very hot topic, and I can't wait to hear his talk. Matt Schultz, who is a venture capitalist, who is going to talk about several of his companies and the way in which our immune systems function like computer systems, like information systems. And then closing off the sessions today will be Steve Bradley from Baylor University on the future of entrepreneurship. So thanks so much for joining us. Well, starting off the day is again going to be George Gilder, after whom these programs are named. And George has a recent book on artificial intelligence, but has actually been dealing with the issue of artificial intelligence for years. In fact, he and I did a book together with Ray Kurzweil almost, I guess, 2 decades ago now on this subject. It continues to be hot. It continues to be a source of a great deal of confusion, both technologically and philosophically. And so George has a lot of very interesting and provocative things to say. And so without further ado, I will hand it over to George to talk about gaming AI. George, thanks.
Great to be here. Do you think your computer is going to rise up and kill you? This is what Elon Musk fears. He says that artificial intelligence is more dangerous than nukes. And Stephen Hawking, the great physicist, thinks that artificial intelligence, this is computers thinking, will be the end of the human race. And my old friend Ray Kurzweil, who's a brilliant inventor, really invented speech recognition and optical character recognition for the blind, and has a whole skein of precocious inventions and ideas, has proposed this singularity that on the way is the prospect that computers will become so much more capable and intelligent than human beings that they will gain the capability to reproduce themselves and reproduce ever smarter computers in a cascade through the universe, leaving us behind in Elon Musk's view to retire to beaches and receive guaranteed annual incomes while Elon and his friends fly off to nearby planets, and artificial intelligence inseminates the universe with really the evolutionary manifestations of ever greater intellectual capabilities, and also because artificial intelligence also encompasses robotics, and 3D printing becomes 3D manufacturing, and so these systems will be able to reproduce themselves mechanically. And according to many of these authorities on the subject, the singularity is near. This really will eclipse and obsolete us. Now, I think this is all ridiculous. I probably have, this is probably evident. But the idea that computers are competing with human minds and will somehow usurp human minds is something out of science fiction. But it's remarkable that secular society and our industrial culture has produced these ideas, and that these ideas continue to excite people and excite fear. I think the fact that Silicon Valley can be terrorized by the concept of artificial intelligence is suggestive of a fundamental cultural disorder that we suffer, that's today manifested by people becoming terrified by a virus, a rather mild virus compared to all the other previous bubonic plagues and flus that have afflicted us through the centuries. The real news is that life is getting much better all the time. You heard Gail Pooley yesterday, I think, the brilliant economist who's been innovating in time prices and can show that, in fact, economic growth and technological progress has been much faster measured by the time in hours and minutes of work it takes to earn the money to buy all the commodities of life. And they have estimate of Thanksgiving dinner, which used to take 30 hours or something to effectively purchase, is now purchased for a few minutes of work by a blue-collar worker. So anyway, I think there is this disorder which manifests itself in the fear of technology. And artificial intelligence is really just the next step in computer science. There's nothing radically new or different about it. It's just the next step. However, the reason people, or at least the reason that is given for the fear of artificial intelligence, has been the success of computers in playing games. And the first great breakthrough was when Watson, IBM, Big Blue beat Garry Kasparov in chess. That was really the first great triumph of AI, or the first great public suggestion that AI might outperform humans in some fundamental way, and that computer intelligence was a competitor for human intelligence. And but actually the big triumph of AI, the first triumph of AI from my point of view, was during the Second World War at Bletchley Palace in Britain, where Alan Turing, who really was a founder of the computer era, along with John von Neumann and Claude Shannon and a bunch of others, but Alan Turing was perhaps the paramount one. He conceived the Turing machine, which is the ultimate all-purpose computer. It was an abstract computer that he conceived, but he really a mathematical construct, but he could demonstrate that this very simple Turing machine that he defined could perform any function that a computer could perform. But Alan Turing was really building on a previous discovery by Kurt Gödel, who was a great philosopher and mathematician in Europe, who produced the incompleteness proof at age 21 or something. And nobody would have noticed it because it was all abstruse mathematics, except John von Neumann was a great sponsor for Gödel. And anyway, Gödel conceived the incompleteness proof, which meant essentially Gödel said that any logical system, any whether it's mathematics or language or software codes or whatever it might be, any logical system is necessarily dependent on axioms outside the system that it cannot prove. And what Turing was doing at Bletchley Palace was to take Gödel's proof, which he achieved through really conceiving a computer software model, mathematical software model, was really the way Turing proved his incompleteness. And Turing said, well, assume that a computer can, an all-purpose computer, can this computer perform can it be self-sufficient? Can a computer essentially be a mind, as the artificial intelligence people imagine today? And Turing, the founder of computer science, really determined that just as Gödel's proof of incompleteness applying to any logical system like mathematics, in the same way, his computer system could not be complete. It was necessarily dependent. Every computer system is intrinsically dependent on an oracle that he called it an oracle outside the computer system. And that oracle, they asked Turing what the oracle could be. And he said this oracle, one thing this oracle can't be, it can't be another machine. And so essentially Turing, in conceiving the fundamental structures of computer science, declared that they were necessarily incomplete. They could not be minds in themselves. They were necessarily dependent on oracles, programmers really, human minds outside the computer system. And this is a basic principle both of logic and of computer science. And then Turing asked, since his systems were all based on numbers, and that they were digital computer systems based on numbers, could a computer compute all numbers? And he found that in all the systems of numbers, many of numbers are completely incomputable. And this is a fundamental limitation of computer science that prohibits these singularities and these computer minds that usurp human minds. Now, for years, I've been writing about computers, and I wrote Microcosm, the history of the semiconductor industry, which was subtitled The Quantum Era in Economics and Technology, and Telecosm, which was about fiber optics and bandwidth and the conjunction of the microchip of the microcosm with fiber optic bandwidth, really infinite bandwidth, and all these. So I've been writing about computers and networks, and in life after television, I've projected worldwide webs of glass and light and air, which is really the global internet we have today. And in doing this, I encountered the question of the connectivity of the entire global internet. How mapping the connectivity of the entire global internet. And this a schematic of global connectivity of network is a connectome. It's deriving from genome and proteome and all those biological concepts. But a connectome of the global internet has been calculated to take a zettabyte of data to map all the connections of the global internet. Takes about a zettabyte. And that's 10 to the 21st power, 1 and 21 zeros. It's almost an incomprehensible number. And so to map the entire global internet takes about a zettabyte. And recently I've been reading about neural networks, a single human brain. And a professor at MIT named Sebastian Sung wrote a book on connectome, in which he calculated the connectome of a single human brain, all the dendrites, all the axons and synapses and linkages in a single human brain. And that adds up, that's a huge connectivity of the human brain. And I was surprised to discover that to map a single human brain takes, how many bytes would you assume? A zettabyte. In other words, a single human brain is as complexly interconnected as the entire global internet. It takes as many bytes to map a brain as it does to map a World Wide Web. And that is, and this shows that this idea that somehow computer systems, binary computer systems, can replace individual human brains is really quixotic. It's really a category error. It's just confusing two different orders of magnitude of complexity and intellectual capability. That global internet, because it uses gigawatts of power, that's billions of watts of power. Well, one human mind uses 12 to 14 watts of power. So the difference of computer technology is just radically and completely different from human minds. It poses no threat. It poses no threat to employment either. I mean, this whole idea that that because robotics and computers are going to become so powerful, we're all going to retire on guaranteed annual incomes. Well, Elon Musk and Bill Gates and Bezos fly off to nearby planets in a winner-take-all universe. That whole delusion is based on the idea that somehow or implies necessarily that human beings are employed because they're unproductive. You know, there are more jobs if human beings are unproductive. If we're all reduced to sticks and stones, everybody will spend all their time just gathering the food to eat. And that somehow is an ideal arrangement because everybody has a job. I really don't understand it, but anyhow, human beings are not employed because they're unproductive. They're employed because they're productive. And robots and AI and automation and all technological advance really makes human beings more productive and thus more employable and better, more creative, more valuable, more inspiring work. So, and AI and the advance of technology, the enrichment of capital yields profits that endow new work, new companies, new initiatives, new work, new jobs, new opportunities. And so I think the whole kind of panic over AI is just, is really ludicrous. And it bespeaks a fundamental philosophical failure of our technical culture. And also the strategic ideas of our business leadership. In Life After Google, I have a critique of Google. Google is somewhat infatuated with the AI notion that it's going to destroy jobs and the catastrophic. But this, it gives it a business plan of rendering its customers and its creators obsolete. And that strikes me as a futilitarian business that obsoletes its customers and renders their work meaningless. And this is, but this is the kind of nihilist philosophy that prevails widely, and not everyone or not, but among many of the people in Silicon Valley. They entertain these fantasies, and I really think they should get over it and just get to work inventing new computer systems that can actually augment human capabilities. And there are all sorts of possibilities. And my COSM conference, which is November 10th to 12th in Bellevue, we're going to be celebrating many wonderful new technologies, some of which promise to obsolete Google, which is some people think these are impossible monopolies: Facebook, Google, Twitter, whatever, that Microsoft. All these companies are imperial forces that have to be regulated and litigated and harassed by politicians and lawyers all around the world. Every few months, one of these companies gets a $5 billion penalty for some obscure antitrust violation or privacy infringement or something. It's all just, I think, a reflection of this catastrophe theory about technology. Somehow these companies are partaking of this cataclysmic AI model, and they got to be brought down to earth, and they got to be broken up, and they got to be sued, and they got to be punished. And this is happening even in China as well as in the United States. And I think it's a real threat to our future, because these companies actually they're just like IBM or Microsoft in previous generations. Everybody thought they were impossible monopolies. And by the time the monopoly lawyers get around to making their case, the companies have ordinarily collapsed and into a real shadow of their previous dominance. IBM is a perfect example. Google gets 90% of its revenues from advertising. These are ads. They call them ads, but they're in fact, as we know, they're minuses. You don't want to see them, particularly on your smartphone. And so, it's been calculated some 30% of all your smartphone bills are paid downloading ads that you don't want to see. That business model has fundamental flaws, and I think we're going to transcend it with the cryptocosm and all these new technologies that we're going to see at Cosmo.
Hey, George, I'm wanting to elaborate. Of course, I agree with you on all this stuff. And so I want to underscore a couple of points. So you talked a minute ago about this idea that robots and smart machines will replace all our jobs is based on the assumption that we're employed only insofar as we're unproductive. And of course, you're pointing out what a lot of economists call this the kind of lump of labor fallacy, that there's this fixed amount of work to be done. And if a machine can do it, then we won't do it, as opposed to the reality, whereas a worker with the tractors, his labor is far more valuable than a worker, with a shovel or with a spoon. And that's, I think, the key point, right? It draws on this lump of labor fallacy that economists all know is a fallacy, but we keep seeming to buy it, especially when it comes to smart machines.
Did anyone who conceived of the lump of labor fallacy? I like that.
I don't know. Yeah, I don't know where the term came from.
That's yours.
No, I use it though. But it floats around in the ecosphere. But that's basically it. It's fixed amount of work. It doesn't change. It's a version of the zero-sum game myth applied to the amount of labor needed at any particular point. And of course, it doesn't follow that this can't be disruptive, because if an obsolete way of working that you're trained in gets replaced by a different way, there could be a transition. But it's saying that it's disruptive is totally different from saying it's going to make us obsolete.
Yeah.
Steve
your book is, what's your book?
Yeah, The Human Advantage. Yeah, The Human Advantage is the sort of development
advantage.
The development of this argument that you've been making sort of filled out. Well, Steve Bradley has a really good question. I know a lot of people are thinking about this because AI, there's also this concept of machine learning, and we have this kind of vague sense that, okay, maybe it wasn't a problem that Garry Kasparov got beat by a machine, because chess is really just kind of a numbers game in which you run different possibilities. But there was this machine a couple of years ago that, of course, won Go, which is a much more complicated sort of prospect. And what was interesting about it was, for one thing, the AI seemed to be following a counterintuitive strategy where it just needed to win by 1 point. So it did things that humans wouldn't do, but also because of being able to play itself over and over, it devised strategies that had not themselves been programmed. I mean, do you think that it poses a new threat, or is this just kind of a different version of the same basic worry?
Well, I think Charles Sanders Peirce really made the crucial point on this. He was the great philosopher at Harvard, a crazy man, wild man, but after he died, they found he'd reinvented all philosophy, and particularly mathematics and technology. And fascinating ways. He's the greatest American philosopher by many accounts today. And as Charles Sanders Peirce said, that reality is not binary, it's triadic. And that computers are all based on on-off switches, ones and zeros, bits, and it's a binary system, a binary machine. But in reality, symbols are necessary. Symbols and computers, of course, like mathematics and all logical schemes, are symbol systems. They're systems of symbols, and symbols do not exactly represent the objects they point to. There's necessarily a human interpretant, as Peirce said, between the symbol and the object. And this gap between the symbol and the object is really where our cognition happens. It's our intellectual domain. And what games are just symbol systems. The symbols and the objects are the same thing. They go, the little stones on the Go board or the chess pieces are symbols and objects. They're all there is. So a computer with its binary gigahertz, billions of cycles a second of computational power can play those games and shuffle those symbols a lot faster than we can with our more complex and capable minds. And they can, the symbols and the objects are the same thing. So they can win those games just as they can calculate mathematical problems faster than we can in our heads, or by analogy, just as a tractor can plow a field faster than a man with a stick.
Right.
All these, it's not a threat that that the computer can shuffle symbols in a game. And it actually illustrates the human advantage, as your book declares it. The human advantage is this cognition, inference, counterfactuals. It's not, our brain is not a machine. It's not deterministic. It can imagine things that aren't true. It can do counterfactuals. It can project futures. It can infer possibilities that may be wrong. It's the human brain is a completely different proposition and different capability than a machine epitomized by a great computer. Computers are wonderful technology,
Sure.
Fabulous invention, but they are not minds.
No, I think that's the
They
key
don't know
one.
any.
They don't know anything. Yeah, and Peirce's insight, I think, is similar to John Searle's in his Chinese room analogy, that computers work at the level of symbols and syntax. They don't work at the level of semantics or meaning. The meaning is our domain. And so, but I guess, there's this, as you said, science fiction assumption that really, on the one hand, we're just machines and we're doing this. So therefore, our machines should be able to do whatever we're doing, including becoming conscious agents, which is a major metaphysical leap. But I think, and people often don't realize that's what's happening. I'm wondering if you think, because certainly, Page and Brin, they said early on that they understood Google and their company search wasn't the main thing they're interested in. They're interested in developing the first artificial general intelligence. And I'm wondering, in terms of business prospects, if there are ways of look, one of us is right and one of us is wrong on these AI questions, right? Either we're right and the machines aren't going to wake up, or they are, right? But a company that's committed to the idea that their machines are at some point going to wake up, I think it, by definition, has a flawed business model, at least with respect to the end. You know, are there venture capitalists betting different ways on this proposition, do you think?
No, I think the practical people actually, I don't think, I haven't, they had a big meeting that I described in Life After Google at a Silomar, where all the great thinkers of, and a lot of those quotes about AI being more dangerous than nukes and were discussed. And at that meeting, if you really took it seriously, they were, you know, we would have declared a crisis and started dismantling our computers, but nobody did. And and the fact was that in the end, their statement was merely that we had to make our technologies serve us rather than serve themselves, which would seem to make sense.
Yeah,
I mean, we just sort of platitudes emerged,
right?
And I haven't noticed any change. Elon Musk may think they're more dangerous than nukes, but he's using computers as much as he can in his Tesla cars and his rockets and his Neuralink connections to the brain that I don't think really are as promising as he does. But anyway, I don't think that that the alarms are being fulfilled at all, and we're just, you know, the companies may get woke, but their machines are not going to wake up.
Yeah, that's nicely put. Even if their algorithms are woke because humans are involved. Well, Nico has a question, a related question having to do with AI and universal basic income. I think both what Nico has in mind here is the fact that the prospect of machines taking all our jobs and machines waking up will make us obsolete. Therefore, we need a universal basic income, but also the idea that government will finally be able to use planning because they'll have access to AI. And so the sort of the calculation problem will be overcome. I mean, what about that with universal basic income and planning?
Well, I think that this point I made about the connectome, that a single human mind is as complex as the whole internet. That's roughly, and uses, and it's 1 billion times more energy efficient, as John von Neumann calculated years ago. He was a real prophet about all this stuff, and I think that throughout history and on into the future, that our economy will thrive to the extent that it decentralizes, as human minds are decentralized. Human minds are not all joined together in some data center next to a glacier somewhere to take off the heat emitted. Human minds are distributed around the globe, and systems succeed to the extent that they are decentralized as human minds are decentralized. And when they try to impose top-down organization, which exalts some few human minds at the top and eclipses the millions of human minds below, you get the horrors of Stalinism and Leninism and Maoist China and all these holocaustic regimes. And I think that that is the key thing, to exploit the capabilities and immediate perceptions and knowledge and learning of individuals, and they can collaborate. Obviously, they succeed to the extent that they collaborate successfully, but they have to use their brains rather than have their brains overruled by some paramount brain at the top of some big government bureaucracy or whatever. And that's, or else you end up with a system that is billions of times less energy efficient and billions of times less knowledgeable about all the vast multiplicity and intricacy of detail that we encounter in our daily existence that governments can't possibly understand. I mean, a good example is in energy. When the government is now mandating electric cars, and the idea is that this is going to prevent CO2 emissions, and CO2 emissions are regarded to be pollution in a ridiculous model that the big brains are entertaining. But the fact is, electric cars are very elegant in themselves. They make great cars, but the systems for fueling them are much more pollutant than oil and gas and that we use with the existing automobiles. And so you mandate something because superficially it looks good. The car itself, considered as an autonomous item, is more efficient and cooler if it's a Tesla. But the fact is, the apparatus requires using all these battery elements and that are rare earths and toxic chemicals that are very hard to dispose of and are much more pollutant than oil and gas. And so it's that kind of mistake you make. Well, the fact is that the evolution of our economy has been steadily away from carbon toward cleaner technologies. If we just let the market govern the evolution of our automotive technology, we'll get self-driving cars, we'll get all sorts of advances, but we won't make the terrible mistake of suddenly mandating that everything be run by a battery that's dependent on lithium that can't be, that is hard to extract and is poisonous, and it's
very hard to get rid of.
Yeah.
I mean, it really is. I mean, people imagine that we could sort of revisit this question of the distributed intelligence of a market versus planning because we have our faster computers or something, but it's never been just a computational problem too. I mean, the problem with socialist planning, especially for things like prices, is it would require telepathy in which you knew everyone's preferences at every particular moment, right? It could price it.
Exactly.
Doesn't matter how fast the stupid computer is, it still can't get into the heads of the people in the market like a market can, but it's distributed. And so this is the kind of the fatal conceit and the great delusion. Well, we want to take a break, and so we're out of time. I know, obviously John Molstetter mentioned his question to the Singularity folks, can you show us a machine that can compose Beethoven's Ninth Symphonies? And of course, he's getting at the point about just the irreducibility of human creativity. And I don't know if you've seen this great new book by Marcus de Sautoy, the British scientist, mathematician. De Sautoy, he's the British mathematician, but he has a book called The Creativity Code. And this is essentially what he argues. I don't know what his metaphysical views are, but he thinks, look, there's just something irreducible about human persons. that can't be reduced to a code that, you know, yeah, which I think is just exactly right along this. Well, George, thanks so much. This is terrific. So